Hi everybody, it's Ms. Burns. I'm going to talk about Lesson 8, the area of triangles. So if you haven't already got yourself situated with your work and a curriculum pen, make sure that you do that. Alright, so here's triangle M, and we're going to look at 3 copies of triangle M. And it says that Han made a copy of triangle M, and he composed 3 different parallelograms using that original copy of M as shown here. So what we have is we have this original M right here, and he made a rectangle, and then we have this original M right here, and he made kind of this longer looking parallelogram, and then we have this original one right here, and it's a little different than looking than this parallelogram right here. But I think we're going to find something really interesting because we're asked to find the measurements for each one and then the area of each one. Remember, when we find the area of a parallelogram, we just simply take the base times the height. And so what we have here, for every single one of these, we have a base height pair that is 4 and 6. So in this example, 4 is the base, 6 is the height. 4 is the base and 6 is the height in the second parallelogram. And in the third one, I'm calling the base 6 and the height 4. But it's still that same 4-6 pair. And that means that for every one of these parallelograms, they have an area of 24 square units. And I think that that's a really cool problem. I hope you take a pause and just look at these parallelograms because they look pretty different, but they all have the same area. It would also tell us that the triangle has the same area. And that makes sense because we know that M is an identical copy every time. So we've just doubled M in 3 different ways to get those parallelograms. Alright, so then we have to find the area of each triangle here. So we're practicing that triangle area work. And so we know that to find the area of a triangle, we just simply find the area of the parallelogram and we take half of that. And so I have right here 1/2 base times height. And so I know that base times height here is 6 times 4, and if I take half of that, I get 12 square units. In this one, I just want to point out that I found the height by going to the opposite vertex, going straight down, making a perpendicular line to like the invisible base right here. So the base is still 4. The base doesn't change when I make that invisible line. The base is still 4. The height is 3. The only reason we would extend the base is just so that we can see and confirm that yes, it does in fact make a perpendicular intersection with that height. And so I'm going to find the area by taking 1/2 times 4 times 3, so that'd be half of 12, which is 6 units squared. In number 3, we have to decide which of these triangles has the greatest area. And what you're going to find when you look closely at these is that they all share the same base height pair. So they all have a 4, 5, 4, 5, 4, 5 pair. And that means all of them, if they were a parallelogram, would have an area of 20 square units. But they're not a parallelogram, they're a triangle. So for each one, we have to take half. And sometimes I like to write it as base times height divided by 2. It's the same thing as multiplying 1/2 times base times height, but it's just a different way to write it. So I'm going to kind of go back and forth. So all of them, because we're taking 20 square units and dividing them all by 2, all of them then would have an area of 10 square units. Alright, so now we're going to find the area of these triangles. Again, 1/2 times base times height. In this first one, both the base and the height fall on the grid line, so we're just taking 2 times 8, and half of that, 16, would be 8 square units. Here we're taking 1/2 times 5 times 4. I got 4 because I went to the opposite vertex. Came straight down at a perpendicular line to the base, and I have a height of 4. So I take 5 times 4 is 20, and half of that is 10 square units. And this one down here in the corner, my base is 7, if I counted that right. It looks 7 to me. My height is 3, and I know that 7 times 3 is 21, and so I'm going to take half of 21, and so my area is 10.5 square units. And you could write 10 and 5/10, or 10.5. And then in the last one, 1/2 times 4 times 6. I feel like we've done triangles like this over and over again with the 4 and the 6. 4 times 6 is 24, and half of that would be 12. square units. Alright, number 5, last turn already. Draw an identical copy of each triangle. So this, you guys, this was hard for me. So I actually put some tracing paper in the crates near your desks so that you could actually work on these problems. There's so many different ways that you could build these. So you could have built it like off this direction. You could have, same with the others. But I just have one example here. So what you're doing in each of these, come on, Eraser. What you're doing in each of these is you are making an identical copy of the triangle so that the two copies form a parallelogram. And so I took an identical copy and I put it down here. I made an identical copy here and an identical copy here. It took a little maneuvering visually. Some of you are going to be way better at this than me because you're good spatial reasoners. So I hope you have fun with that. And thanks for listening.